Electric field due to an infinite wire. Do you know the answer? Of course I know the answer, sir. The answer is 2k lambda by r, or lambda upon 2 pi epsilon naught r. Here, let me write it for you. E for an infinite wire at a distance r. Sir, where is this r along? Perpendicular bisector. Guys, every line which I draw bisects the infinite wire perpendicularly, because every point is a middle point. E of r is 2k lambda by r cap, perpendicular, or lambda by 2 pi epsilon naught r cap. Do you remember this relation? This relation also resembles for a semicircular charged wire. Remember? Good. Now let's derive it. No, let's re-derive it using Gauss law this time. All right. For Gauss law, what is the first thing you need? Sir, Gaussian surface. Good. Gaussian surface should be what? Now I will walk the talk. Gauss law says that integral E dot ds over a closed surface is Q enclosed upon epsilon naught. Correct. What are you using Gauss law for? Sir, we are using it to derive electric field. Correct. Where is the electric field in the expression? Sir, it is inside the integral sign. Correct. In order to use this result to find out E, which is an unknown, it is inside the integral. You need to get it out. Hear me again. In order to find electric field, you need to get it out of the integral sign. Yes, sir, we do. Correct. When does something come out of the integral sign? When does something come out of the integral sign? Crudely speaking, when it is constant. Correct. That means your Gaussian surface, come on, that means your Gaussian surface should be chosen in such a way that it is symmetric about the charge distribution you are finding the electric field for. I'll repeat. The choice of Gaussian surface should be in such a way that the electric field over the boundary of that Gaussian surface should be uniform, so that it is able to come out of the integral sign. If you don't choose a Gaussian surface like that, or if such a Gaussian surface does not exist, then plain and simple. What is plain and simple? I cannot apply Gauss law? No. You can. But you are stuck. You can't do anything about it. Please understand the difference. Please understand the difference. You can apply Gauss law, but it is not going to give you anything. Do you understand that? It is not a condition to apply. It's condition for utility. Okay? Okay, sir. Got it. Tell me, for a line, what is the most symmetric thing you can figure out? For a line, I think, sir, a cylinder. Fair enough. You already know the direction of electric field. It's actually going outwards perpendicular to the wire. Correct? Because that is the only ONLY. That is the only unbiased direction. Sir, why should it be unbiased? Because for an infinite charge distribution, you can't be biased towards any direction. Alright. So take a cylinder now. This is the best part. Best part. Are you ready? Stop writing. Stop writing. Stop writing. Sir, it's an infinite cylinder. Aye. So should I consider Sir, it's an infinite line charge. Aye. So should I consider a infinite cylinder? Why would you think that? Because don't you think we have to enclose the charge? Correct. Then our size of the cylinder should be infinite to enclose the whole wire. You have a point. I like the way you think. You have a point. But I have a point too. And I'm going to dazzle you with that point. No. No, you don't need an infinite cylinder. But sir, then some charge will be outside the cylinder also, no? The entire wire cannot be enclosed in a finite cylinder. Correct. So, what so? Forgot something. Electric field in the LHS is due to all the charges in or out. So who cares? Oh, I forgot that.